Welcome to our Prezi, the first slide. The rules of sig figs. Non-zero digits are always significant. Any zeros between two significant figures are always significant. The final zero or trailing zeros in the decimal portion are only significant. The rules of sig figs explained. Rule 1. Hopefully this rule seems rather obvious. If you measure something and the device that you use returns a number to you, then you have made a measurement decision and the act of measuring gives a significance to that particular number or digit. In the overall value that you obtain. The number like 26.38 would have 4 significant figures and 7.94 would have 3. The problem comes with numbers like 0.00980 or 28.09. Rule 2. Any zeros between two significant numbers are always significant. Again, I hope this one is obvious. If we have a number like the number shown there, the first 4 zeros would not be significant because those zeros are just placeholders. But the zero between the 9 and the 3 is significant because it comes between two significant numbers.
Yeah.
Rule 3. All trailing zeros or the final zero is significant. Here are some examples of significant figures with trailing zeros that are significant. Now here's a fun rule called the Atlantic Pacific Rule so that we can remember how significant figures work. The Atlantic Pacific Rule says, if a decimal point is present, ignore zeros on the Pacific side. If the decimal point is absent, ignore zeros on the Atlantic side. Everything else is significant.
How to determine the number of sig figs. Zeros within a number are always significant. Both 4,308 and 40.05 contain 4 significant figures. Zeros that do nothing but set the decimal point are not significant. Thus, 470,000 has 2 significant figures. Trailing zeros that aren't needed to hold the decimal point are significant. For example, 4.00 has 3 significant figures. If you are not sure whether the digit is significant, assume that it isn't. For example, if the directions for an experiment read add the sample to 400 milliliters of water, assume the volume of water is known to 1 significant figure. Subtraction and addition of sig figs can be no greater than the least accurate measurement. When measurements are added or subtracted, the answer can contain no more decimal places than the least accurate measurement. For example, multiplication and division with significant figures. We count significant figures in each measurement, not the number of decimal places. When measurements are multiplied or divided, the answer can contain no more significant figures in the least accurate measurements. Why use significant figures? It provides people with a method of reporting the level of accuracy of the measurement. It also provides a systematic method of rounding calculations that involve scientific measurements. If we did not have significant figures, we would see crazy numbers each day. On the speedometer, we would see numbers like 59.8889 instead of 60 miles per hour.
So this next slide is a video that I found extremely helpful when recording sig figs. In the video, if you just go into your browser, type in significant figures crash course if you need any extra help. I found it super helpful, and I would just click to the next slide, but it's about 11 minutes long. But if you just want the part about sig figs, just go up to 720.